Right, this is integration by parts, and here's the formula here. There's two versions of it. They're both the same thing really, just written in different ways. Here's u dv dx is uv minus the integral of v du dx. And if u was v and v was u, you'd have integral v du dx is equal to uv, or vu, same thing, minus the integral of u dv dx. I personally most times write this one when I'm doing things, so I start with a v. Now here, this is an x. This is a product. And if we haven't got something we could recognize where a constituent of it differentiates to a scalar multiple of what's beside, and we don't think we can use substitution basically, and that trick, then because it's a product we look to use parts as the other tool in the tool bag. Here you've got a 50-50 chance of getting it right, so I'm going to label that v and this du. The reason I'm doing that is because the u here will be e to the x, and the dv will be 1. So this integral will be 1 times e to the x dx, which is an integral we can do. So I'm on the first step and I step down. Had this been a x squared, say, then this would be a 2x e to the x, and you'd get an integral. The point is that you start with the difficult integral and you get to an integral that's more easy. You see, this would be x squared e to the x, this would be 2x e to the x, so you step down. So things like this, sometimes you need to reapply the parts formula and step down twice and do the same thing again. Here we're only going to need to step down once, aren't we, because it's just an x. So let's see that in practice then. So I think of integrals that look like this as going down a series of steps. Here it's just one step because that's x to the 1, and you'll see what I mean when we look at this integral over here. The one step and then you can do the actual answer. So let's try it then. 50-50 chance. If it doesn't work and you look like this is more difficult to solve, then you've taken a step away from the solution. So swap them around and do it again. Okay, so v is equal to x and du, I'll just write in du shorthand, is equal to e to the x. So dv then will equal 1, and u, integrate du to get u, and the integral of e to the x is e to the x. So I'm writing the shorthand notation v du, because sometimes we don't bother with the dx here and here, we just write it like that. So in other words, integral v du is equal to uv minus the integral of u dv. So this is just a shorthand way of writing it. Okay, but it's the same thing. So I equals then, let's see what we get. Now it's uv, so these two, x e to the x minus the integral of u dv dx. So those two multiplied together. 1 times e to the x is e to the x. Can you see that this integral is easier? So we did make the right choice. So we've got x e to the x, and this integrates to e to the x, plus a constant of integration. There's the solution.